Hello, welcome to a true demand-based train routing system in Factorio 2, space age without any mods. Yeah. So the goal of the video is to show you the train routing system. The goal of the train routing system is that trains should only ever idle at the depot stations over here, never at any of the pickup or drop-off stations. That in combination with that all the trains should be in the same train group, so they all have the same schedule. Uh, let's start with a small demo. We have some depot stations over here, so there's 4 depot stations. We have some sinks, some drop-off stations, so this is where iron ore gets shipped to. We have some sources, some pickup stations over here, in this case 4. And the goal of the train routing system is that when we start up the system, that only 2 trains should leave to pick up iron ore and then deliver them to the sinks, to the drop-off stations when they're full, empty it at the sinks and then go back to the depot. So what we don't want to happen is that all 3 leave because there's room at 3 sources, because then one of the trains will, when it's full, idle because there's only 2 places to store its contents. So let's start the system and see what happens. All right, so that's already 1 train leaving. All right, the second train is leaving. So this one is going there, this one is going there. What's happening to this one? Nothing, nothing, nothing. Well, yeah, it's not going to go to the source station. So 2 will start filling up and then we'll go to the sink so we can take a look at their respective schedule. So they go to the source now and wait till they have a full cargo of iron ore. Then they go to the sink, to the drop off, and then they empty it again. Okay, so how does it work? Let's take a look at the train routing system. It has 5 components. So there's the clock, which is over here. Then there's the depot stations, which are over here. So there's 4 in this case. There's the pickup stations, also called source stations in this video. So those are over here. And if we zoom in, we have 4 of them. They all have some buffer. So in this case, 6 chests, and some logic, of course. There's the sink stations, which are over here. So the drop-off stations, which also have some logic, also some buffer chests to hold items. And then there's, of course, the trains themselves. And let's go over them one by one. Let's start with the first component, the clock. So there's the basic clock, and then there's the an arithmetic combinator. So the basic clock, yeah, it's a clock, so it counts up to 300 and then resets back to 0. So this is how you set up a clock. You feed the decider combinator back into itself and have a constant combinator with a value of 1, so it increments always by 1, the raw fish value. So the raw fish is our clock. We'll need that later. We'll divide this value by 3 so that it only increments by 1 every 3 game ticks instead of every game tick. And we feed that signal into the radar. So in Factorio 2 space age, radars have wireless transmission and they broadcast the attached signals to all other radars on the same planet. So that's pretty handy. Let's take a look at the second component. So the sink stations or the drop-off stations. So it has 2 decider combinators and the actual station for the actual sinks. This one, wait, let's go out of the way a bit. Sorry. So this one is actually a source. So let's take a look at the right tree. So let's take a look at this far right one. So there's 2 decider combinators. The first decider combinator, it checks this. So it checks if there is enough room in the station. So in this case, I indicated it by if it has more than one train load full, then please don't come here anymore to load it up even more full. So we can see when we indicate this by the amount of iron ore should be less than 2K. So 2K iron ore fits in one train wagon. So that is this condition and outputs it on the L signal. So that's what it checks, and it outputs a 1 on the L signal. So if it's less than, it will output this value to the station, and that will set the train limit. Then we have the second decider combinator, which actually reads the same value. So the red wire is connected both here and both here at the input of the decider combinator. It checks also the same, so the amount of iron ore is also less than 2000, but it outputs it on the iron ore channel. So this then means, well, let me check. It sets the green channel's item value to +1 of that particular item and sends it to a radar. So now the entire train system knows there's at least space for one train load full of items of that particular item, in this case iron ore. So that's what the green signal means. So aka one train full load of iron ore fits here, and that's output on that that signal, this signal. We will need that later for the depot stations. Then we have the train station itself, which is set by the first decider combinator, the train limit. So if there's no space, it should set its train limit to 0. And also it should read the train count going to the sync station and send it to the iron ore channel again, but this time on the red channel. So you can see that there's a red wire connected to all the stations and then connected to the radar. So it will send on the iron ore channel, the red iron ore channel, how many trains are going to this particular station. So there's two values for each item in the circuit network. One on the green channel, one on the red channel. The green one indicates how many full train loads do we have space for at sync or drop-off stations, and the red one means how many trains are currently underway or at the station of that particular item. So we'll need both for the depot station. Let's take a look at the source station or the pickup station first. That's over here. It's similar to the sync or the drop-off station. Sorry, the source station is a pickup station. Sorry. So here there's a pickup station. There's space. In this case, again, 6 chests, and we have only one decider combinator for every source. It checks: do we still have enough of that particular item to fill an entire train load? So one wagon in this case. That's what I'm using, and output it on the L signal. So this signal is then propagated to the actual train station, which also will send that value, will set the train limit. It also reads the train counts and also outputs it, that value, on the red channel of that particular item. So that's actually, so the red ones are also connected and also connected to the radar. So it will send, if a train is going to either a source station of iron ore or a sync station of iron ore, it will increment the red circuit value of that, or of the iron ore channel. So we have now everything we need to take a look at the depot station. That's the fourth component. The depot stations take the green and red channels. So here are the depot stations. So we can see that both the green line is connected and the red line is connected to read both those values. And this is where the magic happens. So this is the decider combinator where everything kind of comes together. So we read the first value, the green value of each of the channels, and subtract it from the red circuit channels of each of the channels and output it on their respective channels. aka the green channels mean how many space, so how many trainfuls of space in sink stations or drop-off stations do we have? So in this case, we have 0 space left because we just did our drop-offs. But and we subtract from that how many trains are actually underway. So what we should see happen is that indeed there's still 2 trains on the way, but there is not room, and so this is getting quite full, not room for any more in those drop-off stations. So the difference is this value, and this value indicates how many more trains can we add to the network to do deliveries. And so to not to be guaranteed that we can actually drop off the items that we pick up. So that's what this value means. This value is then sent to each of the depots, but what happens first is that it's filtered based on the clock. So this is where the clock comes in. So if we take a look at this left one, we see that the value of the fish should be equal to 1 for this depot station. And if it is so, then we output the input signals. So we just output everything that we get onto the output. For this one, it's set to be equal to 2. For this one, it's set to be equal to 3. So it's kind of an identifier. Each depot has its own integer value assigned to it. So this means that only one depot will be active at any given time, and the value increments every 3 game ticks. So every 3 game ticks, a different depot can launch a train. So this is to prevent that 2 trains decide to go somewhere at the exact same time, because otherwise that messes stuff up. Yeah, all our counting logic takes some actual game tick time, so the decider combinators need to propagate through the network, so that's why it's set to only increment every 3 game ticks. So we have the arithmetic combinator, which calculates how many more trains we should add. Then we have the decider combinator that is only active every so often. And this signal is then sent to the actual train station, which simply sends it to the train. We don't need this actually. So which actually just simply sends it to the train. The actual depot station always has a hard-coded train limit of 1. So let's take a look at the final component, which are the trains. Where are my trains? They are all in the depots over here. I have some extra depots over here. They're all hooked up in the same way, but I just have extras. So let's take a look at the train. So this is they're all in the same item delivery train group, and they have the same schedule, but for each item you would need to add an interrupt for which items you want to transport. So let's see what the actual schedule says. So we have source is not full and the circuit condition should be higher than 0. So when the circuit comes in, this value, so this is the subtracted value that we have. So how many more trains we can add? It should be greater than 1. But we have an additional condition that says the source should not be full. So this means there is enough space at the sink stations, so the drop-off stations, to drop off whatever you pick up. But this means, yeah, don't go there yet because the source is still busy. You might go there later, but right now it might not be such a good idea. If you go, you will need to queue at the source station, but not at the sink station. So you can remove this, but it's not optimal. But it will still work. It should still work. So if those 2 conditions are active at the same time, then go to the source stations, fill up, and then go to the sink station and empty your cargo. And that's it. So you can add an extra interrupt to refuel. And then for each item, you should individually add the interrupt, which is kind of a drag, but I didn't find a way to do it with generics. And that's it for the train routing system. Let me know what you think, and thank you for watching. Bye bye.